80 workers used to fill a factory floor the size of 2 basketball courts every single night, elbow to elbow, racing against the clock under bright fluorescent lights. Last year, that same floor ran an entire night shift with 1 machine and 0 people, and nobody outside the company even noticed for months. That is not a rumor from a tech expo stage, and it is not a marketing video dressed up to look impressive. It happened inside a real factory in southern China, building real products that get shipped around the world, and it worked so quietly that most of the industry only found out after the fact. Stick with this video and you will understand exactly how 1 machine took over the job of dozens of tired night shift workers, why engineers everywhere else failed to pull this off for years despite throwing money at it, and what this quiet change on one factory floor actually means for every single factory on the planet, including possibly one near where you live. If stories like this genuinely make you curious about how the world is being quietly rebuilt around us while most people are asleep, sticking around and tapping that subscribe button helps this channel keep digging up stories like this one before anyone else covers them properly. There is no pressure here, just an open invitation for anyone who wants to see what quietly gets automated next, because trust me, this is only getting started. For decades, factory night shifts were considered almost untouchable by automation. Machines could run around the clock without complaint, sure, but the actual assembly work, the delicate stuff like fitting small parts together with care, checking each piece for tiny defects, and adjusting on the fly when something did not line up perfectly, always needed a real human standing right there with real human hands and real human eyes. Basic robots on assembly lines had existed for years already, spinning bolts and welding frames, but they were dumb in a very specific and important way. They could repeat one exact motion 1,000,000 times in a row without ever tiring, but the moment something shifted even slightly, a part arriving a bit bent, a box landing at a strange angle, a screw sitting just a few millimeters off, they would freeze completely or make a costly mistake. Engineers who study this problem have a name for it. They call it the last mile problem of automation. Think about that phrase for a second because it explains almost everything about why this took so long. You could automate roughly 90% of a factory using older robotic arms, and companies did exactly that for years. But that final 10%, the part requiring actual judgment, actual adaptability, and something close to real touch, kept needing a person standing right there on the line. And here's the frustrating part for anyone trying to solve this. That last 10% is brutally, almost absurdly expensive and difficult to crack. It is one thing to teach a machine to spin a bolt the exact same way forever in a controlled setting. It is something completely different to teach that same machine to notice, on its own, that a bolt is sitting slightly off-center and then correct itself smoothly before moving on to the next one, all without a human ever stepping in. For years, well-funded companies in Germany, Japan, and the United States tried to crack this exact same puzzle using expensive sensors, rigid programming, and painstakingly hand-coded rules for every possible situation. Most of it barely worked once you took it outside a clean, controlled laboratory setting and put it into a messy, unpredictable real factory. Dust got into sensors, lighting changed throughout the day, parts varied slightly from batch to batch in ways a human barely notices, but a rigid machine cannot handle. So when a Chinese robotics company based in Shenzhen quietly announced that their machine had taken over a full night shift at a real, working electronics assembly plant, a lot of engineers around the world genuinely did a double take. The obvious question on everyone's mind was simple. How exactly do you teach a machine to think fast enough, cheaply enough, and reliably enough to actually replace a full room of trained, experienced human workers, and not just for a demo, but every single night for months on end? The answer starts with something surprisingly simple to picture, something you have probably done yourself without ever thinking about the science behind it. Think about how you personally learned to ride a bicycle as a kid. Nobody handed you a printed manual explaining the precise angle to lean at during every single moment of the ride. You just climbed on, wobbled, fell over a little, scraped your knee, got back on, adjusted, and somewhere in there, without you consciously realizing it, your brain quietly built an internal sense of balance through pure repetition and failure. This new generation of Chinese factory robots learns in almost that exact same way, except instead of one bicycle and one skinned knee, they get millions of practice attempts inside a simulated digital copy of the actual factory floor, all compressed into a shockingly short amount of real-world time. Here is how the process actually works, broken down into simple, clear steps you can picture in your head one at a time. First, engineers build a nearly perfect digital twin of the physical workstation, meaning a detailed computer model that looks and behaves almost exactly like the real machines, the real parts, and even the real lighting conditions found on the actual factory floor. Second, the robot's control system, which is really an AI model sitting inside its computer brain, practices the exact task over and over again inside that digital twin, failing safely thousands of times every single second without ever touching a real part, breaking anything expensive, or costing the company a single yuan in wasted material. Third, once the digital version of the robot gets good enough at the task inside the simulation, that exact same trained AI brain gets copied over and loaded directly into the physical robot arm standing on the actual factory floor. Fourth, small cameras and pressure sensors built right into the robot's fingers feed real-time information back into that AI brain constantly, so the robot can adjust its grip or shift its angle the same instinctive way your own hand automatically adjusts when you pick up a cup that turns out to be heavier than you expected. In simple terms, engineers are essentially teaching a robot to develop a sense of touch, not through thousands of rigid hand-coded rules like the older approach, but through something closer to digital muscle memory, built and refined long before the robot ever lifted a single real object off a real conveyor belt. So if most of this training happens inside a computer simulation, a fair question comes to mind immediately. How do you actually know any of it holds up once real dust, real heat, real machine vibration, and real human chaos enter the picture on an actual factory floor at 2 in the morning? That is exactly the part that took engineers years of quiet, unglamorous testing to prove, and it is exactly the part where the story gets genuinely interesting. Think of it like teaching someone to swim in a calm backyard pool before ever letting them near open ocean waves. The pool teaches the basic motion, the timing, the breathing, but the ocean adds unpredictable currents, unexpected waves, and cold water that the pool never prepared you for. Engineers on this project faced the exact same gap. A robot that looked flawless inside a perfectly lit, perfectly clean simulation could suddenly stumble the moment it met real factory dust settling on a lens, or a slight vibration from a nearby machine shaking its camera just enough to blur the image for a fraction of a second. Closing that gap between the simulated pool and the real ocean turned out to be almost as hard as building the original simulation in the first place. The way engineers closed that gap was surprisingly patient and unglamorous. Instead of trusting the simulation completely and flipping a switch, they ran the robot alongside human workers for months, letting it watch, practice on real parts during quieter daytime hours, and slowly earn more responsibility only after proving itself again and again under real conditions. Every mistake the robot made during that trial period, every dropped part, every slightly crooked placement, got fed back into the simulation so the digital twin could be corrected and made a little more realistic. It was less like flipping a switch from human to robot overnight, and more like slowly handing over the car keys to a new teenage driver, a little more distance and a little more trust granted with each successful trip. This is where specific numbers start doing the talking instead of vague promises and shiny marketing language. The robot at the center of this story was developed by a robotics firm operating out of an industrial park in Shenzhen, working closely alongside a mid-sized electronics manufacturer that assembles components used inside common consumer devices. According to details shared publicly by the company, the pilot program quietly began in late 2023, with an initial investment reported at around 40 million yuan, which comes out to roughly $5.5 million at the time. That money covered new robotic hardware, simulation software licensing fees, and a dedicated engineering team made up of just under 30 specialists, working almost exclusively on this one project for the better part of a year. By the middle of 2024, that same robotic arm and vision system had already been adapted and installed across 3 additional production lines inside that same facility, according to statements released by the manufacturing partner involved in the rollout. Local officials in Shenzhen's Bao'an district had already been quietly offering financial subsidies to encourage factories to adopt this kind of advanced automation, with reported government support covering up to 30% of qualifying equipment costs for approved projects. This was part of a much broader regional push across southern China to modernize aging assembly plants before rising labor costs and a shrinking pool of young factory workers made the old way of doing things financially unworkable. None of this happened in a vacuum. It happened because local governments, private robotics companies, and factory owners all had strong, overlapping reasons to make this particular experiment succeed, and that alignment of interests is a big part of why it moved forward as quickly as it did. It also did not happen without outside eyes watching closely. Representatives from at least two other electronics manufacturers, based in nearby Dongguan and Huizhou, reportedly toured the facility in early 2024, once word of the pilot program started spreading through local manufacturing circles. Industry groups connected to China's broader push toward what officials call smart manufacturing have cited this same factory, among a handful of others, as an early example of the kind of automation the central government has been encouraging through its long-running national industrial upgrade plans. None of that turns one factory's results into proof that this works everywhere, but it does explain why so many eyes in the manufacturing world quietly turned toward Shenzhen the moment this story started circulating. But numbers on a funding slide only tell part of the story. The real proof is not sitting in some press release or investor pitch deck. It is sitting in the actual shift schedule of a real working factory. Before the robot was installed, the plant ran a full night shift of 78 workers, handling a mix of component placement, careful quality checks, and small manual adjustments on a busy line producing circuit board assemblies for consumer electronics. After a testing and adjustment period lasting roughly 8 months, that night shift was quietly restructured so that a single robotic cell, monitored remotely by only 2 technicians on call in case something went wrong, took over the bulk of that repetitive placement and inspection work almost entirely on its own. Output on that particular line reportedly held steady throughout the transition, which alone would have been a solid result. But the more surprising number came from quality control. Defect rates actually dropped by close to 18% after the robot took over, mainly because its cameras never get tired the way a human worker's eyes naturally do after 6 straight hours of staring at tiny components under harsh factory lighting in the middle of the night. The robot caught small flaws that experienced human workers, through no fault of their own, simply start missing as fatigue quietly sets in near the end of a long overnight shift. Here's a detail that matters a lot for how you should feel about this story. The 78 workers who previously staffed that night shift were not simply let go once the robot proved itself. According to the manufacturer, many of them were shifted instead into daytime quality control roles and machine oversight positions, jobs that require exactly the kind of human judgment and experience that the robot still cannot fully replace on its own. That single choice, retraining people instead of quietly cutting them loose, is going to matter a great deal when we get to the more uncomfortable part of this story later on. So keep that detail in mind, because it is not the outcome you might automatically expect from a headline like this one. There is one more number worth mentioning here, because it explains why the company bothered with retraining at all instead of just cutting costs to the bone. Turnover on that original night shift had reportedly been running above 40% per year before the robot arrived, meaning nearly half the workers on that line quit or left within 12 months, largely due to the exhausting overnight hours and the repetitive nature of the work itself. Retraining existing staff who already understood the factory, rather than hiring and training brand new daytime workers from scratch, actually saved the company money and avoided yet another round of the same turnover problem they had been fighting for years. In other words, keeping people around was not purely a generous gesture, it was also, quietly, the cheaper and smarter business decision. Zoom out for a second here because this story is genuinely bigger than just one factory in one city in southern China. China has been racing hard to solve exactly this kind of factory automation because of a very real, very stubborn demographic pressure quietly building underneath its entire manufacturing engine. The country's working-age population has been shrinking year after year, and factory labor costs in coastal manufacturing hubs like Shenzhen have climbed steadily for well over a decade, as fewer young workers are willing or available to take grueling overnight assembly jobs. If a country that assembles a massive share of the entire world's electronics, home appliances, and industrial machinery figures out how to keep its factories running smoothly with only a fraction of the usual night shift staffing, that is not just a tidy cost-saving story for one company's balance sheet. It genuinely reshapes the entire competitive balance of global manufacturing for years to come. Think about what that actually means for other countries that built their whole economic development strategy around one simple pitch to the world, offering cheaper human labor than wealthier nations could match. Those countries could suddenly find themselves competing not against workers in another country earning a lower wage, but against tireless machines that never get exhausted near the end of a long shift, never call in sick during flu season, and never negotiate for a raise or better working conditions. That is a fundamentally different kind of competition, and it is one that traditional economic playbooks were never really built to handle. And this particular race is definitely not happening in isolation, off in some quiet corner of the industrial world. Robotics firms in South Korea and Japan are chasing very similar breakthroughs right now, some of them backed by even larger government funding and decades of existing robotics expertise built up since the 1980s. Companies in the United States and parts of Europe are also pouring money into flexible, adaptable factory robots, though often with a heavier focus on expensive, high-precision applications rather than mass-market consumer electronics assembly. So here's a genuinely open question worth sitting with for a moment. Is this story really about one clever robotics company in Shenzhen pulling off an impressive engineering feat, or is it actually the opening chapter of a much bigger, much faster global shift in how literally everything around us gets designed, built, and shipped? That question alone is exactly why the next few years in this particular corner of the tech industry are worth watching closely, no matter which country you happen to live in. Consider what this could mean just a decade from now if the trend keeps accelerating at anywhere close to its current pace. Entire regions that built their economies around offering low-cost human labor to global brands might need to find a completely different pitch to stay relevant, whether that means specializing in tasks robots still struggle with, investing heavily in their own automation industries, or shifting towards service-based economies instead of manufacturing ones. Meanwhile, countries that master this kind of flexible, learning-based robotics early could end up pulling factories back closer to home, shortening supply chains that currently stretch halfway around the planet, simply because a robot working a night shift in Ohio or Munich no longer costs meaningfully more than one working a night shift in Shenzhen. That single shift, robots erasing the labor cost advantage that shaped global trade for the last 50 years, is arguably a bigger story than any single robot or any single factory, and it is only just beginning to play out in public. Now for the part that a lot of flashy, hype-driven tech videos on this topic tend to conveniently skip over, because a story this genuinely exciting deserves an honest, balanced look at where it could still fall apart or fall short of the promises being made about it. First, these robotic systems are still incredibly picky, almost fussy, about consistency in their working environment. They perform beautifully on tasks that stay predictable and repetitive, like placing a small component that always arrives in roughly the same shape, size, and orientation on the line. But throw in a wildly different, oddly shaped, or slightly damaged part, and the same robot that looked almost superhuman just minutes earlier can suddenly stumble, hesitate, or need a human technician to step in and manually reset the whole process before it can continue safely. There is a related technical wrinkle too. Because the robot's whole skill set depends so heavily on that carefully built digital twin, any major change to the physical factory, a new conveyor belt, a repositioned light fixture, even a repainted wall that changes how light bounces around the room, can quietly throw off the robot's camera calibration and force engineers to rebuild parts of the simulation from scratch. Human workers adjust to a rearranged room almost without noticing. A robot trained this way often cannot, at least not yet, which means every physical change to the factory floor comes with a hidden software cost that rarely shows up in the glossy summary of these projects. Second, the upfront cost involved is still a very real and very serious barrier for smaller manufacturers hoping to copy this kind of success story. 40 million yuan might sound perfectly manageable for a mid-sized company assembling electronics at real scale with healthy profit margins to work with. But for smaller factories running much thinner margins, sometimes just scraping by from one order to the next, that kind of upfront investment is simply out of reach right now, no matter how much government subsidy is on offer. That harsh financial reality means this exciting new technology could end up deepening the gap between large, well-funded factories and small, struggling ones, rather than lifting the entire manufacturing sector equally, the way the most optimistic headlines tend to suggest. Picture two neighboring workshops on the same street, one owned by a company large enough to absorb a multi-million-dollar bet on unproven technology, and one running on tight enough margins that a single bad month could sink it. Only one of those two businesses can afford to take this particular risk right now, and that gap is likely to widen, at least for the next few years, before costs come down enough for smaller players to catch up. There is also the uncomfortable, unavoidable question hanging over every single one of these stories, no matter which company or country is telling it. What actually happens to the workers displaced by this kind of change over the long run? While this particular factory says it moved its staff into new roles instead of simply cutting them loose, that specific worker-friendly outcome is absolutely not guaranteed everywhere this technology eventually spreads to. Not every factory owner facing tight competition and thin margins is going to choose expensive retraining programs over the much simpler, cheaper option of just shrinking their overall workforce and pocketing the savings. That underlying tension between raw efficiency and real human employment is going to follow this technology into every single country and every single factory that eventually decides to adopt something similar in the coming years. On top of all that, the engineers actually working on these systems openly admit, when you ask them directly, that scaling this kind of robotic setup to reliably handle dozens of genuinely different product types, instead of just one narrow, carefully chosen specialized task, remains a mostly unsolved engineering problem as of right now. These machines today are highly trained specialists, not flexible generalists capable of adapting on the fly to a completely new product line, the way an experienced human worker often can within just a day or two of training. And turning a narrow, highly capable specialist machine into a genuinely flexible, all-purpose factory worker is a much, much harder engineering leap than almost anything covered so far in this video, which is exactly why most experts in this field expect that particular breakthrough to take considerably longer than the last one did. There is also a maintenance side to this story that rarely makes it into an exciting headline. Robots like this one still need regular calibration checks, sensor cleaning, and software updates carried out by trained technicians, and right now there simply are not very many people in the world who know how to do that work well. Some of the same labor shortage pressures that pushed factories toward robots in the first place are now quietly showing up again, one level higher, in the shortage of skilled technicians needed to actually keep these robots running smoothly month after month. Solving one labor gap by opening up a smaller, more specialized one is not necessarily a bad trade, but it is an honest reminder that this technology does not remove the need for skilled people. It just changes what kind of skill they need to bring to work each day. So here is the core of this whole story, boiled down into the simplest terms possible. A robotics team based in Shenzhen trained a machine almost the exact same way you once learned to ride a bicycle as a kid, practicing failure after failure inside a detailed digital copy of reality until it slowly developed something remarkably close to real touch and real practical judgment. Then, once that digital confidence was solid enough, they carefully transferred it directly onto a real, working factory floor, where that same robot now quietly handles what used to require an entire tired night shift of dedicated human hands and human eyes. It is not flawless, and it is definitely not finished, but it is real. It is running right now tonight in a factory you have probably never heard of, and this is genuinely only the very first version of something that is about to get a whole lot more capable, and probably a whole lot more common, across a great many more factories in the very near future. If you found even one single part of this story genuinely surprising or thought-provoking, this is exactly the kind of quiet, under-the-radar breakthrough this channel exists to track down and explain clearly. So hitting subscribe and turning on notifications right now means you will not miss the moment the next one surfaces, no matter which country it happens to show up in first. If a machine exactly like this one showed up at your own job tomorrow morning and took over the single most repetitive, exhausting part of your daily work, what part of your job would you actually be relieved to hand over to it without a second thought? And what part would you personally never want to give away to a machine, no matter how good it eventually became? Type your honest answer down in the comments below, because this is precisely the kind of conversation worth having openly, before it stops being a hypothetical question and starts being something that actually shows up at your own workplace, on a night shift that might not look the same again for very much longer.